Hello everyone. Welcome to the mini lecture on electromechanical control technology. Today, we will explore a fundamental and key concept in mechatronics control technology, open-loop control systems. I hope that through this lesson, you will gain a new understanding and insight into open-loop control systems. Our lesson will cover the following 4 main topics. Through this lesson, I hope everyone can understand and explain the definition, workflow, and main features of open-loop control systems. Analyze and identify the advantages and limitations of open-loop control systems in practical applications. Before we dive deeper into open-loop control systems, let's first understand the basic concept of a control system. A control system is a complex system that adjusts the behavior of the controlled object through various methods, ensuring it operates according to the expected goals or instructions. Based on whether they include a feedback mechanism, control systems are mainly divided into 3 types: open loop, semi-closed loop, and closed loop. 1. Definition of open-loop control system. An open-loop control system, as the name suggests, is a system that does not include a feedback loop in the control process. This means that the output of the controller directly acts on the controlled object without considering the actual response or output state of the controlled object. In other words, an open-loop control system is a unidirectional, feedback-less control strategy. 2. Workflow of open-loop control system. The workflow of an open-loop control system is relatively straightforward. First, the input value of the controller is set according to the actual needs or goals. Then, the controller calculates the corresponding control signal based on this input value and directly passes it to the controlled object. Upon receiving the control signal, the controlled object will perform the corresponding action or response. During this process, the open-loop control system does not monitor the actual response or output state of the controlled object. 3. Features of open-loop control system. 1. No feedback mechanism. The biggest characteristic of an open-loop control system is the lack of a feedback mechanism. This means the system cannot adjust the control input based on the actual response or output state of the controlled object, which may lead to uncertainty in control effectiveness. 2. Simple to implement. Since there is no need to consider a feedback loop, the design and implementation of an open-loop control system are relatively simple, and the cost is also low. 3. Wide application. Although open-loop control systems may lack precision in control, they are still an effective control strategy in many application scenarios. For example, in applications with lower control precision requirements, or when the characteristics of the controlled object are relatively stable, open-loop control systems can perform well. 4. Applications of open-loop control system. 1. Constant speed motor control. In certain situations, we may want a motor to operate at a constant speed. In such cases, we can use an open-loop control system by setting the controller's input value to directly control the motor speed. Of course, this control method is based on the assumption that the motor's load and characteristics are relatively stable. 2. Temperature control system. In some simple temperature control scenarios, we can also use an open-loop control system. For example, in winter, we may want the room temperature to stay within a certain range. In this case, we can directly control the room temperature by setting the heater's power. However, it is important to note that when external environmental conditions or internal room conditions change, this control method may not achieve the desired control effect. Through today's lesson, we have gained a comprehensive understanding of open-loop control systems, their concepts, working principles, and features. Open-loop control systems are suitable for applications such as temperature control, timers, and industrial production lines, and their output is not influenced by feedback signals, providing a high degree of stability. Lastly, Please think about this lesson and complete the following exercises to consolidate today's knowledge points and deepen your understanding. That concludes our lesson for today. See you in the next lesson.